So there's this term in regional development that has been going around for a few decades now, and it's called sprawl. The implications of spatially spread out development are well documented, having impacts on environmental health and resource distribution, among other things. One method of combating the effects of sprawl is called infill development. I will allow presenter Chloe Jackson to explain this in greater detail, but a roadblock that often discourages infill development but is also critical for protecting hillside areas from major development in Pima County is something called the Hillside Development Overlay Zone. Chloe's project produces a model and visualizations for where these areas can be found in Pima County to optimize the development process. Chloe.
Thanks, John. So thank everyone for coming tonight. It's good to see the turnout. This is my model of the Hillside Development Overlay Zone for Pima County Development Services. So I'm going to start with a little bit of context. This time, actually a little bit earlier last year, Pima County updated its comprehensive plan with a document called Pima Prospers. And in this document, infill development is specifically defined as a goal for increasing the density of the urban core. Infill development can be defined as just very simply situating new development inside existing communities that have vacant or underutilized areas. And this sort of reflects the shifting trend away from sprawl towards more dense communities in urban design theory. Author and landscape designer Peter Calthorpe defines some of the reasons why this is a more desirable pattern. First of all, you're less dependent on cars. It also makes mass transit and green infrastructure a lot more efficient. And most importantly, it makes development, or it promotes development on a human scale. So these areas are walkable, they're more diverse, and they're more mixed use. On top of this, another author on the topic is Stephen Wheeler, who argues that local government, so Pima County, is specifically suited for making this kind of change. So they're the link between local long-term land use planning and the developers themselves. And he also argues that this is not going to happen overnight. It's going to be a step-by-step process, incremental policy changes towards that larger goal. So this project is going to attempt to be one of those step-by-step processes. First objectives come from Pima Prospers directly. To develop the tool will be the model of the zone, and then to reduce zoning barriers to infill will be how that zone how the model informs the way the zone threatens infill currently. And then the third objective, we want to do both of these without corrupting the purpose of this zone. So as John mentioned, the zone we're talking about is the Hillside Development Overlay Zone, or HDZ. And the purpose is to preserve the character, identity, and image of Pima County. So view sheds that hillside areas create is something that's very characteristic of our area. This zone applies to any land that has 15% or greater slopes with a 7.5-foot rise and 50-foot run in any horizontal direction. Once you measure that, you've triggered the zone, and then you need to measure your average cross slope, which is a different measurement. That's the total terrain over the total area of your site. So that determines what you have to then do. So it determines how dense your housing units can be. It determines how much grading you can do on your site. And it determines things like your paint, color, and reflectivity requirements. So if your dream house is a sparkly castle on a hill, you're slightly out of luck, unless you go through some of the avenues for getting around that. So first, if you know where HDZ is, you can just develop not in that spot, and you avoid the requirements. You can get a design or a HDZ exception from the Design Review Committee. So they'll go over your site and maybe come up with extra conditions for you to deal with these requirements. So why is this a problem for infill development? The first problem is that there's no way to know where it is. There's no visual representation of the zone. So previously, if you wanted to know if it was on your site, you would use your average cross slope to sort of guide you, but we've seen that's not the same measurement. So what was happening is a lot of the impact area was flying under the radar. The second problem is that this zone triggers outside of hillside areas. So if you've had a lot of grading on your site, it triggers easily if you're near a wash, and it triggers if you're near a mine site. So these are areas that are generally in the urban core and would otherwise be candidates for infill. You can think of a scenario where a developer comes to Pima County with a completed design, and the average cross slope didn't indicate HDZ, but somewhere along the way we discover it's there. So the full redesign is going to be time and money that they may or may not be willing to deal with. So this is how it becomes a barrier. The solution is to build this model. So this was done using the ArcPy module for Python to string together tests that represent the 15% slopes with 50-foot run and 7.5 rise. I chose to script it because it needed to be a consistent process that could be repeated over and over again as the data changes. Thankfully, Pima County has a pretty robust GIS department, and they have a system for dealing with that. Their job scheduler opens up the H2Z model and runs it every Saturday morning at 4 a.m. if you want to get up really early. So the first thing the script does is it references existing Pima County data. So what you see in the background there is the elevation model. This was built using LiDAR bare earth elevation points, and where we didn't have those, it was the national elevation data set. And the resolution is approximately 10 feet. The next bit of input data are the parcel boundaries. So this is what changes on a daily basis. They can be combined, they're split, or change ownership. So the first thing the script does is it references that most recent version of that data. And then it performs selections on it to get what you see in red here. We only wanted to work with parcels that Pima County can enforce its code. So that's why you don't see the Tohono O'odham Nation in there. You won't see anything that's been incorporated into a city or any of the federally owned lands. The second step is to measure slope. So from the elevation model using the Esri slope tool, which measures the percent slope for every cell based on the elevation values around it. And then a conditional statement goes through and selects only the ones that are 15% or greater, which is that first part of the HDZ definition. The second step is to measure rise and run. Before we do that, we want to cut the slope features to the parcel boundaries. And the reason being, if you have a large slope feature in a tiny parcel, you're only going to want to measure rise and run for the portion of that slope feature that's on a parcel. So once we cut them, we have hundreds of thousands of candidate features for HDZ. We measure the rise of those first, so that's done by, for each of those features, looking back at that elevation model and seeing what the range of values is inside of it. And then another conditional statement will choose only the ones that are 7.5 feet or greater, which is what you see in orange. The last step here for measuring HDZ is to measure the run, and because it's 50 feet in any horizontal direction, this is done using a minimum bounding geometry tool. And one of the things that tool does is it measures the distance between every pair of vertices for every candidate feature. So you can start to see how this takes a long time to run. Once it measures those, it picks the longest one and attaches it to the candidate features, and then the script can go through and pick the ones that we want based on how confident we are. So what I mean by that is anytime you're taking real-life data and putting it in a computer model, there's abstraction that's going to occur. So to deal with that, anything that's really close to the HDZ definition was considered to be possibly HDZ or needing more examination on the ground. And so that was 40 to 60 feet in length. Anything that was 60 feet or greater was considered confidently HDZ. So the last couple of things to incorporate here were an arrow trapping system that Pima County uses for its scripts. This was extremely useful. How it works is essentially it goes through those tasks to measure slope or to measure HDZ, and if it fails, it gives me this email. So I got this email every day for probably at least a month. But it came with a list of print statements so I could see where it had failed, and then it collected all of the ArcGIS and Python error messages so I could see how it had failed, which was great for troubleshooting and testing. It's usually a comma. The last thing that it does is it updates, or it takes those results and puts them in a format that can be pushed up to MapGuide, which is Pima County's user interface. So staff can see data layers, they can share it with customers, and then anytime or certain layers are available to the public. So these are the results. This is the Hillside Development Overlay Zone in eastern Pima County. If you zoom in, you can really see how it pulls out both hillside areas. This is Keystone Peak, but also extra areas. So just on the right side of your screen, you have the mines that are just west of Sahuarita. If you zoom in a little bit more, you can see how the washes are triggering HDZ very easily. This is the Catalina Foothills area. This is what HDZ looks like on MapGuide. So if you were a developer and you came in, we would pull up your parcel or what you were interested in building on, and then we would overlay all of this information that you would need to know. So we would also have things like flood control data, land use designation, and now we've got HDZ. If you zoom in on MapGuide, you can see the green areas are HDZ, and even that tiny little drainage is triggering this zone. If you take away the imagery, you can see how on the site here, previous grading has triggered HDZ, so you can actually see the parcel bound or the building footprint, which is a testament to how fine that elevation data is. Oh, the last thing I'm going to show you on here is possibly HDZ. So those two features there, they're a little hard to see, were measurements that were close enough to the definition that we decided they needed to be examined more closely. So what does all of this mean for Pima County? So the HDZ model is available on MapGuide for staff currently and will eventually be available to the public. It's an automated analysis with weekly updates, and anything that was missed when average cross slope was the determining factor is now included. But the biggest thing is that the size and the location of HDZ is known. So this is what's going to improve the efficiency of developing on parcels in the urban core where HDZ has triggered, where it's outside of the hillside area. If you think about a developer who's looking at those areas, knowing about those design requirements from the get-go is going to save so much more time, it's going to save a little bit more money, so there's no fees for HDZ exceptions. Knowing about those design requirements also means that we haven't improved, or we haven't removed hillside protection, we've actually improved it. So the zone didn't change, the design requirements didn't change, and those design requirements were made to protect these areas. So developers who are looking at this area are going to have to be more sensitive to slope, more sensitive to the visual aesthetic as a whole. So all of this amounts to one of those incremental steps that we started out talking about. So this is going to be not even a policy change at this level. This doesn't need to be approved by the Board of Supervisors. This is simply a model of the zone that allows people to be more informed about developing. We've already taken a look at the next steps. So this is in progress. This is looking at where we can actually remove the zone from the urban core. And we're doing that by sort of shrink wrapping HDZ to where the features are most dense. That's what it looks like right now. This is obviously still in progress, but this would be an actual change to the zoning code, which would go to the Board of Supervisors. So keep an eye out for it. This is the end of my presentation. If anybody has any questions, please feel free to ask me. Otherwise, thank you for your time. Tell me when to stop. This one? I'm not sure I had pictures in the first three. Oh, okay. So this is actually, just for your viewing pleasure, this was one of my tests. Because the data was so big, I had to use a small subsection. So this is Ajo, Arizona. That's a giant open pit mine. It's closed now, but the features are obviously still there. So that's one of the examples where mines really pop out. That's actually the question slide, too. Oh, that's a tailing. Tailing, I don't know what it's called exactly, but that's where they pile all the stuff that they took out. I guess tailing pile would work. Peter?
I'm assuming your mom's not perfect. Your process is perfect.
No. Yeah, Peter.
Does she use Peter? I was going to say.
Not at all.
Yeah. There's hope for it. So what could it do better? Where would you want to take this to enhance it?
I would want to use LiDAR data as much as possible for more of it, and more recent LiDAR data. Because the date on the LiDAR data is either 2008 or 2005, and generally the elevation isn't going to change too much. But there are cases, because HGZ triggers on as small a scale as a building footprint, that does change, and the grading on a site does change, so that would be good to know. If it's, I think there's even a picture of it. Yeah, so if you can see the building footprint, where's the laser pointer? Oh, you turned it off. If you can see the building footprint almost right in the center, there is no building there currently. So that's the most recent imagery that we have. Oh. Right here, there's no building there. It disappeared. So that could just be a remnant of the grading on the site, but it could also be out-of-date LiDAR data.
Did buildings themselves cause any issues in defining your zones?
As far as I know, no. You do see the footprints popping out, but that's because of the site grading. You want it to build on a flat surface.
Okay, this is just visual.
Yeah.
The building on the left there,
This one.
I can't really see a whole lot. You have to get the area one. You can't see a whole lot of grading, but maybe that's just an artifact of the area. It looks like the building itself made that line down. Yeah, I know, but what caused that was the elevation of the building. There's actually a gradient system there.
Yep. Yeah, things like landscaping can do it too. This, where'd it go? I'll just let you guys figure it out. This, or possibly feature here, is one of those little like riprap things at the end of a drainage to stop dirt from getting into the street, so landscaping can affect it. But given the definition of the zone, that's okay, because we're strictly going by 15%, 50 foot, and 7.5 feet. Not as far as we've seen. So I guess I should mention that this is only in use for staff right now because we want to look for cases like that. Oh yeah, and it was bare Earth points. That was the real answer.